Haiti. This shows you what's called a shake map. A shake map estimates what the perceived shaking is at the ground surface. Okay? And this is called the modified Mercalli scale. It's these Roman numerals are used. It goes from 1 to 10. These colors correspond to these colors here. And you can see when you get up here to the 10, that is extreme. Okay? You can see here's Port-au-Prince. Here's the shake map. And you can see that we had ground shaking in here that was considered much greater than 10. So the velocities in that area exceeded 116 centimeters per second. The acceleration is 124% of g. Okay, so very intense ground shaking in Port-au-Prince. And I'm sure you've got some pictures of the damage. These pictures were taken by my husband when he was down in Haiti. And I'll talk about what they were doing in just a second. Okay. In contrast, here's the shake map for Chile. Okay. You don't see here on land where the people are any red. So if you look, it was only a 6 down here, which is considered strong, very strong, but not the violent shaking that you had in Haiti. Okay. And you can see the velocities are much, much lower, and the accelerations are much, much smaller as well. Okay. So that's a primary difference. Okay, here's another difference between Haiti and Chile. This is now damage from Chile. And this looks a lot like the damage in Haiti. If you look at these pictures, you'll notice they don't look like these pictures, the damage in these pictures. And one obvious feature is there's a boat in the middle of town. Okay? So that tells you that not only was there an earthquake and an earthquake-associated damage, there was also a tsunami, and we'll talk about why that is in just a second. All right, so if you look at the Haiti earthquake is a left lateral strike slip event that corresponds to this. You can imagine if you have pieces of the earth moving, they can move apart from each other, they can move into each other, or they can move side to side. 3 types of motion, 3 types of fault, and that's what we see here. And the event in Haiti was a strike slip fault where one side moves relative to the other side horizontally. Okay? Characteristics of strike slip faults, they're near vertical. They only have seismicity down to depths of about 15 or 20 kilometers. Below that, the crust gets too warm, and so you can't generate the fault rupture. And side-to-side motion like this, so you're not going to get a tsunami. As long as you only have side-to-side motion, you're not going to have a tsunami. The Chile earthquake, in contrast, is a thrust fault, like this. You saw the arrows in one of the early slides where the Nazca plate is moving toward the South American plate. They're moving together, and so now you have the 2 pieces moving toward each other. This generates a thrust fault. Okay? That just shows you that. Okay. Characteristics of thrust faults: the faults are angled, they're not vertical. Seismicity, if you have a thrust fault in the subduction zone, which is the interface between the 2 plates, is a megathrust. Okay? You can have seismicity down to hundreds of kilometers, hundreds and hundreds of kilometers. You get up and down motion, so there's vertical motion associated with this, which equals the possibility of a tsunami. And why is that? Well, here's the subduction zone. One plate descends below another, here. So here's the Nazca plate, here's the South American plate. These are earthquakes. You can see that they go very, very deep. Whereas in strike slip faults like in Haiti, you can't do that. Okay? The other important thing is you can imagine if you have 2 plates like this, with the subduction zone, where you can have earthquakes down to very, very deep, instead of only very shallow, there's a huge surface area that can break in an earthquake. The larger the surface area that can break, the greater the magnitude of the earthquake. Okay, so if you look at where the largest earthquakes have been between 1900 and 1996 on this diagram, magnitude 8 or larger, they're all along subduction zones. So you can't get earthquakes, the largest earthquakes, anywhere but subduction zones. That's just a feature. Okay, so subduction zone generated